So this picture is included in your textbook, okay? And if you don't take a little bit of time to sort of analyze what they're saying here, it can be very confusing. So let's take a nice patient approach to this graphic here, and it says that we can use that first theorem, right? So it calls it theorem 8.1.1, which I just hate, but basically with the right triangle, and if you have the altitude going from the right angle to the opposite side, how it creates those three similar triangles, okay? But we use that theorem to write proportions comparing the side lengths of the triangles formed by the altitude to the hypotenuse of the right triangle, okay? And so it says all of the relationships in red involve these geometric means, okay? So just as I always do, I'm going to go through and use a couple different colors just to sort of say what we mean here, okay? So this first one, right, so we have these, the biggest triangle, we have the medium-sized triangle and the smaller triangle that are formed by that altitude, okay? And so this first ratio that they're talking about is basically this distance right here, which they call B, and then this distance right here, which they call A. So they're basically comparing the long leg to the short leg right here in a B to A ratio. And then they do that same thing here in the medium-sized triangle. They say this is now going to be a Y to H ratio, okay, which is represented right here. And then they say this is now a H to X ratio, okay, which obviously, again, is expressed right here. Now, what they're saying here is that these ones in red, okay, they represent geometric means, right? So if we did the cross products property here with just the ones in red, we would get H squared equals Y times X, or X times Y, okay? And then we could either say that, or we could say that H equals radical XY. All right, and so that's all they're actually saying here, is that this relationship is actually created, okay? Now we can go through the other ones and let's discuss what we're talking about here. So now they're talking about the relationship of the hypotenuse of the biggest triangle, which is C, okay? And they're comparing that to the shorter leg of this triangle, which is here, right? And so again, that's where we get that C to A ratio, okay? Where we get the B to H is, again, the hypotenuse to the shorter leg, okay, which is right here, okay? And then finally, again, the hypotenuse to the shorter leg, which is right here. So that's the A to X ratio. Now again, the ones in red, if we I'm just going to sort of cross this one out for now. If we use this cross products property now, we get the fact that A squared is going to be equal to C times X, okay? And so again, if we look back at this and what we're actually saying here, okay, we're saying that this red value right here, okay, or this red length here, if we square that, okay, that's going to be equal to this entire length times this length right here, okay? So it's important that we kind of understand what we're actually saying there, okay? And we can also express this again as that A equals the square root of C times X, okay? That's also fine. All right, and let's look at this very last relationship here, okay? I'm going to do a little bit of erasing of the red stuff here just to kind of help us out just a little bit. Okay, and we're basically back in action here after I do a little bit more stuff here. Okay, and now let's look at this very last relationship where we're comparing C to B, right? So if I compare the length of this hypotenuse to the length of the longer leg, that's what we get right here. Okay, so we'll do again the same thing now. It's B to Y, so again the length of the hypotenuse to the length of the longer leg, which is right here. And then again, the length of the hypotenuse to the length of the longer leg, which is right here. That's A to H. Okay, so if we just use the red ones, we have the geometric means there, right? We have the means that match up, so we get B squared is going to be equal to C times Y. Okay, or we could express this as B is going to be equal to the square root of CY. All right, now, again, let's look and see what this actually means. So let's look at maybe just this portion right here. So we're saying that B squared, so this side right here, the length of this side, squared is going to be equal to the length of C, which is this entire thing, multiplied by Y, which is right here. Okay, now again, I know this is sort of confusing, all right? So just sort of be patient with the relationships that we just derived here. But we'll definitely look at lots of examples here so we're nice and comfortable.